Good morning and welcome to today's Solving Puzzles with Python. Without any further ado, let's head over to today's puzzle. So, question 18. We all know that pi can go on for an infinite number of decimal places, but what actual difference does the number of decimal places make to, say, measuring the circumference of the Earth? We're used to hearing about pi to 4 decimal places or 5 or 6 decimal places, but does this make much of a difference when you're measuring something like the circumference of the Earth? The formula for measuring a circumference using pi is the circumference of a circle is 2 times pi times the radius. We're going to do this in Colab. We don't have to. There's nothing special about the coding we're going to do today. No graphical objects, no special libraries. Going to do it in Colab, but feel free to do it in the translator of your choice. So here we are, and here's the beginning of our code. We're going to use this version of pi. We won't use all of it. We'll just use the first 8 decimal places, I think, in this example here. No reason for that. It's just a bit more convenient than using all these decimal places. You can make it as long or as short as you like. Perhaps one interesting thing to note is that we're going to use pi in the form of a string. You can tell this is a string because it has the speech marks either side of it. We can't use integer because integers whole numbers only, and we're definitely going to be using decimal places. If we use real numbers or float numbers, you might find that their rounding errors get introduced. But if we use a string, the idea is we can increment through every value of pi and just tell the computer to use that absolute value and not to do any rounding. So here's our next line of code, a simple print statement to introduce our answer, print pi2 and then string length pi minus 2. So we have our string pi and we're going to print out the length of it minus 2, and that will denote the number of decimal places, because the whole string length is, I think, 10, but we're only interested in quoting the number of decimal places, and the first 2 characters are nothing to do with the number of decimal places. So by taking 2 away from the total length, we're telling everybody how many decimal places we're going to be working to. So we can print that, we can run that, and there we are, pi to 8 places. Now our next block of code is a little bit more complicated. We're using a for loop to scroll through our variable here, our string variable containing pi. It's going to go numerically from the second place to the last place, to the length of pi. There's not much point in using the first 2 characters. We know what they are. They're 3 and decimal point. We are going to tell our code to simply pull down the next value after the 3 point. So first of all it'll do 3.1, then 3.14, then 3.15, and so on and so forth. It's easier to show you than explain it. We have some print statements here, and when I run it, it'll probably be a bit more apparent. So our introductory statement, pi to 8 places, the index is 2, index there, it starts at 2, and the next pi digit is a 1, so the next pi digit is a 1 here. So total pi is 3.1. We're appending the 1 to the 3 point. Next running of the for loop, the index is incremented to 3, the next pi digit is a 4, so total pi is 3.1 with the 4 put on, and then 3.141, 3.1415, 159, and so on. It just goes through this string here, taking the next character in turn, and it'll stop when it gets to the end because we're only running to the length of pi. If we made pi an awful lot longer, it would accommodate that as well. So here we have a way of incrementing through pi, and we can then use this value here into a calculation involving the circumference. So now we have another line of code in here that actually does the calculation. I've introduced another variable at the top just below pi called radius. When we do the circumference of the Earth, we will use the radius, which is half the diameter of 6371 kilometers. We're just going to start off with 100 just to get our calculation working. So with the radius of 100, we're going to take our current value of pi, convert it to a float. It won't do any rounding because there's no numbers after it. It'll just take our absolute value because we're starting from this end, and multiply it by 2 and multiply it by our radius, and we've got a print statement here telling everybody what our program does. The circumference for a radius of is da da da. So let's just run it and it'll probably be more apparent what is going on. So pi to 8 places, pi value of 3.1 gives us a circumference for 100 radius of 620. Now we increase pi by 1 decimal place and that takes it to 628. Another decimal place, 3.141, and it's gone up a little bit from 628 to 628.2. Here you can see the effect of rounding and the effect of the computing. I haven't bothered to correct it, but the computer has, you can see the precision of the computer here, and it has come up with that value, all the zeros with a 1 at the end. It's managed to find an absolute value for 3.14159, which it couldn't do for here, and we get 628.38. So you can see by increasing our value of pi from 1 decimal place to 8 decimal places, we have the circumference has gone up from 620 to 628.3 units. Let's try another value in there. Let's try 22145 for absolutely no reason whatsoever. 22145. It's as good a number as any. And you can see that the circumference changes from 137,299 to 139,141.13. You can see where the computer plays with the precision. You can adapt the code to limit the number of decimal places, but I thought I'd leave it in there. So let's answer our burning question. The radius of the Earth is 6371 kilometers. So 6371 kilometers. So run that. So the circumference of the Earth, if you're going to travel around the equator using 1 decimal place, you'd need to travel 39,500 kilometers. If you're going to run around the equator at 2 decimal places, your run would be only 500 kilometers more, 40,000. 40,022 kilometers, that's not much of a difference. 40,028 kilometers, and so on and so forth. 40,030 kilometers for 8 decimal places. So there we have it. A simple program there that gives you a variety of answers and shows you the difference the difference precision can make, the difference the number of decimal places can make. And that's it for today. Thank you.